number 1 is to determine the domain of the function. First of all, you look at this and remember domain has all about to do with the denominator. What will make the denominator 0? So you set it equal to 0 and you solve. You set each factor equal to 0 here, so x is 0 and x squared minus 9 is 0, so x is positive or negative 3. So these are the numbers that will make this 0, so we can't have those. So the set of all numbers x such that x cannot equal 0 and x cannot equal positive or negative 3. We don't have to say anything about all real numbers, we just have to say that because that just means that it can be all numbers except for those. There's your domain. Number 2, given f of x is 7x to the 5th, find f inverse. Well, so you change the f of x into a y, then you switch x and y, and solve for y. Okay, that's this process here. Okay, we get y to the 5th equals x over 7. Then you have a choice. You can either take it to the 1/5 power, or you can do the 5th root. Either way, both are correct, both will work. I'm giving you both right now because one or the other may appear on your exam. And it is a function. How do I know it is a function? Because there's no plus or minus. Anything with an odd exponent, when we're solving, there's no plus or minus. Even exponents, yes, you have the positive or negative. Number 3 was graph the piecewise function. Okay, you have the paper, but your boundary line is x equals 3. Okay, so I hope you can see this. I drew a vertical dotted line at x equals 3. Then what I did is I plugged in 3 into each piece of the function. When I plugged it into 2x minus 3, I got 3. It's a circle on 3, and then my slope is 2. So then I'm just going to go up 2 over 1. Oh, but I don't want that side because this is for when x is less than 3. I would need this part of that line, so I'm going to go down 2 and back 1. Down 2 and back 1. My slope is still positive 2, but I'm on this side of the line 3. I did the same for the other one, negative 2x plus 2. I plugged in 3, and I found what this point should be. Then I used my slope, negative 2 over 1, negative 2 over 1. There's that piece of the function. Number 4 was graph the inverse. Reflected across the line y equals x. Okay, the line y equals x is the line that passes through the origin, and it has a slope of 1. When you reflect the original, this is what it'll be. And I just picked a few points. The easiest way to do that is to pick a few points that are on the original, switch the x and the y's. Number 5, describe how y equals the absolute value of x minus 2 plus 3 can be graphed from the parent function. Well, here's your parent function. The minus 2 means you're going to translate 2 units to the right. I don't know why I wrote left, but 2 units to the right. And the plus 3 means you're going 3 units up. Number 6, 7, and 8. All 3 of them go together, and they go with the use the compound interest formula, and they give you the formula. We are given all the variables, what they all stand for. Okay. Number 6 says, find the interest rate to the nearest tenth of a percent, given that this is the amount you want to end up with, so that's going to be your ending balance. This is the amount you're going to start with. You've got 7 years to invest. Okay, so in the process, we divide by 1,500, so we get 5 over 3, which you would probably do 2.6 or 2.7, knowing you guys. If you do abbreviate it or round it off, you're going to get a different answer. And it might even be different than anything that's on your test if you don't do it this way. Okay, I'm using the 1/7 power. Again, 1/7 power means the 7th root. You can do either one. When we get to here, 5/3 to the 1/7 power is here. 1 plus r, we subtract 1. Well, r is your interest rate as a percent. They're asking for the percent to the nearest 10. Okay, so it's 7.6%. Number 7 says to write the formula. Okay, this is find the inverse function basically given a real life situation. We want to write the formula for solving for r. So here we did it with real numbers. Here we're going to do it without knowing. We just solve for r. Okay, so same process. Okay, one or the other. 7th root, there's no plus or minus. Number 8 is just calculate your ending balance given the information. So you plug it in and do the math. This is the one where we're writing the polynomial function given the roots. And I keep saying x minus the root, x minus the root, x minus the root, and multiply it out. Anybody that came to me with that question? When you multiply these two, this is going to give you the difference of two perfect squares. Okay, so it's going to be x squared minus 9. Now we still have to multiply by the x minus 3. When we do that, this is our equation. Okay, number 10, I changed number 10 because this number 10 does not have a rational root. So I wanted to give you a new one that actually does have a rational root. Okay, so it's x cubed plus x squared plus 2x plus 2. It says use the rational root theorem and the remainder theorem to find the roots of, so we got to find all the roots. Starting with the rational root, here's your possible rational roots. Remember, the possible rational roots are going to be p over q, where p are the factors of 2 and q are the factors of the leading coefficient. Well, the leading coefficient is 1. That's nice. So that means plus or minus 1 and plus or minus 2 are our only possible rational roots. So we test them. I started with testing with 1, and then I found that -1 is a rational root. Can you use your calculators to do this? Yes, of course you can. Okay, but this is how you do it without the calculator. Okay, when you do the division, okay, the calculator, by the way, is only going to give you the rational root. It's not going to give you these two roots. So you're going to have to end up dividing by it anyway. So that's why I choose to do it by hand to begin with. When you do the division, we get x squared plus 2 equals 0. Solve for x, we get an imaginary x is positive or negative I square roots of 2. Number 11, graph the equation. This is given to you in standard form. So I choose to do the x and y intercepts, and that just means when x is 0, tell me what y is. So when x is 0, I've got -5y equals 15. Y is -3. And when y is 0, tell me what x is. That's 3x equals 15. There's 5. Plot the points, draw the line. 12, how is g of x related to the parent function? Well, the +2 means it's translated 2 units left. -1 means it's translated 2 units down. 1 unit down. The 1/2 out front means there's a vertical compression by a factor of 1/2. If this were a 2, it would be a vertical stretch. Stretch makes it longer. Compression makes it shorter. Graph the inequalities. Okay. I did these in pen because I wanted to make sure you could see them a little better. And then since I was doing these in pens, I realized this is just a greater than, but I drew the line solid. So like some of you do, I draw little dashes in there. That means it's dotted line. Okay, then you check to see where to shade. We're going to shade above. Okay, now, I didn't shade over here. because anything over here is not in the domain. Why? Because if I put in a number like -3, I'm going to have -1 under my square root, which in the set of real numbers, which is all we can graph, -1, the square root of -1 is not there. So you have to shade only on this side of the vertex and above the line. Okay? 14 does not have a domain issue. Okay, so we just graph the line, or the curve in this case, and pick which side of it to shade. Okay, 15. 15 is describe the end behavior. Well, the degree is odd, the leading coefficient is positive, so the end behavior is here. As x approaches -infinity, g of x is also approaching -infinity. As x approaches infinity, g of x is also approaching infinity. 16 and 17, more graphing. 16 is a rational function, so we had to find the asymptotes. Okay, 16, the vertical asymptote is given to you. That's going to be what will make the denominator 0. So that's my vertical line there. The slant asymptote, you have to divide. You're going to take the x squared and divide it by x minus 2. And the result's going to be this line here, which I believe is x plus 2. Okay, so once you do that, you get your slant asymptote and the vertical asymptote. Then you can use the calculator to figure out where the curves go. 17, graph the function and its inverse. Okay, it's an absolute value function. There's the original function, and here is the inverse. Okay, again, you don't have to actually find the inverse to graph it. All you have to do is pick these points and then switch x and y. That's all you have to do when you're graphing the inverse. In these two roots, find two more roots. You're going to use the conjugate root theorem. These are irrational numbers. Technically this one's not, but I guarantee on the exam it will be. 7 minus the square root of 4 is the conjugate pair to 7 plus the square root of 4. And then 2 plus the square root of 7 is the conjugate pair to 2 minus the square root of 7. 19, graph paper. Here is the graph of number 19. Number 21. 21 is another piecewise function. Okay. Here we've got 2x, and I see that in the domain it's between -2 and +3 and including those. So I started at 0 and I just went up 1 over 1, up 1 over 1, up 1 over 1 till I got to +3. Down 1, back 1, down 1, back 1 till I got to -2. That's the piece of that line that I need. The other line is a horizontal line at 3, and that's from 3 to 15. There you go. 22 real quick. Find the vertical, horizontal, and slant asymptotes. Starting with the verticals. This is the denominator of the function. Factor it. Set each factor equal to 0. These are the vertical asymptotes. How do you know if it has a slant asymptote? Well, the degree of the denominator is less than the degree of the numerator by 1. That means it's got a slant asymptote. How do you find the slant asymptote? You divide. And you should use long division. Actually, you have to use long division with this equation. Synthetic division is only possible if you have a linear divisor. This is a quadratic divisor, so synthetic division is not possible. 3x plus 4, y equals 3x plus 4 is the slant asymptote